everybody, welcome back. We're going to begin the second part of 3.4, which is dividing polynomials, but this time we're going to look at synthetic division. We're also going to take a look at the remainder theorem and also look at the factor theorem. And in both of those, I think the factor theorem is the most important, okay? So first of all, synthetic division is a method used to divide a polynomial by a linear expression in the form of x minus a. So that's really important, okay? No coefficients in front of x. I mean, you can divide, but it gets kind of messy. So for our purposes, we're only going to divide by a factor x minus a, okay? And this is kind of what it looks like, and we're going to go over it in detail, okay? So here's long division right here, what it looks like, and here's synthetic division. So you can kind of see that it's very simplified, just a couple of rows of numbers, and we end up with kind of the same thing, okay? The process, you don't have to write all this down, but just kind of absorb it a little bit, okay? So here we have divide this polynomial by x plus 4. Notice that now what we do first of all is write down all the coefficients of the dividend. So we take this 2, 6, and then we have a 0 here. We always want to fill in whatever power is not represented. So since there's no x term, linear term, we put a 0 there. So we put a 2, and then a 6, and then a 0, and then 29 for our number term. And then we're going to divide by a negative 4. Okay, so we're going to change the sign of the constant in the divisor. And what that allows us to do now, instead of having to subtract when we do this part down here, we can just add straight up, okay? So we're always dividing by the 0, if you think about it that way, okay? So my 0 here would be negative 4. So we're going to divide by that negative 4. So that's really, really important, okay? So we're always going to start by bringing down the first one, okay? And then we multiply and then add, multiply and add, multiply and add. And I'll show you that process in a minute. When we're finished, these are all coefficients of my quotient. And their coefficient is 1 power less than we started. So this will be 2x squared minus 2x plus 8. And then the last term here is my remainder. Okay, so this is a little bit confusing right now, but that's kind of the structure. And then we're going to go through it right now. Okay, so let's go ahead and show you how to divide synthetically, synthetic division. So first thing, if you remember, is we're going to divide by my 0. So what is my 0? Is going to be a positive 3. Okay, and we always put it like in what we call the house. Going to put it in the house. And then I'm going to write down all of my coefficients here. Make sure, first of all, do we have every single power represented? It's cubed, squared, first power, and a number. Yes, we do. Okay, so my coefficients are 1, negative 5, negative 2, and 24. Okay, I'm going to leave myself some space and then draw a little line. Okay, we always begin by bringing this number straight down. That's my very first step, is we take this number 1 and bring it straight down. Okay, then what we do is we start this pattern. It's a pattern where we take this 3 and we're going to multiply it by 1 and put it right here, and that's going to be 3. Okay, then what we do is we add these two together, which is negative 2. Okay, and then we do it again. I should actually put that as a different color here. Now I'm going to leave it. Let's make it purple. Okay. Purple's not much different, but that's okay. Okay. Then we're going to do the same thing again. And we continue to multiply this 3 by this number, negative 2. Okay. And then it goes up here, which would be negative 6. And then we're going to add those again. And this is pattern all the way through. This becomes negative 8. And then again, we multiply 3 by negative 8. And that becomes a negative 24. And in this case, we end up with a 0. Okay, that is my remainder. And in this case, my remainder is 0. And that's super important. And we're going to talk about that in a little bit. When my remainder is 0, that is kind of special, because that means that this x minus 3 is actually a factor. It goes into that evenly. So remember, when we rewrite this, our quotient here is going to be x 1 power less than we started. So x squared minus 2x minus 8, and a remainder of 0. So each of these are a coefficient of my quotient there, and then it's just 1 power less, and that's it. Okay, so if I were to actually write this in factored form, this is my quotient. Can't write very good with this pen. If I write this in factored form, so it's very important to know the difference between these two. Oh my gosh, my pen is not writing very good. Factored form. This would be, I take my x minus 3, right? That's what I divided by. Since there's a remainder of 0, that means it's a factor of this x squared minus 2x minus 8. If I multiplied these two together here, I would end up with that guy, okay, because those two are factors. Because I have a remainder of 0, those two are factors. We're going to talk a little bit more about that in a little bit, okay? Okay, so let's try this again. Let's divide again. So this time we're going to divide by the 0, which is 5, okay? So we're going to write our 5 here, put it in the house, and I'm going to make sure every power is represented. So 4, 3, 2, 1, 0, that's perfect. So I'm going to write all of my coefficients: 1, -3, -7, -11, and -20. I'm going to leave myself a little bit of space, and I'm going to write a little bar there. I'm going to bring down always this first number 1, and I'm going to start my multiplication process. Okay, 5 times 1 times 5 is 5, and I'm going to add those together, and that is 2. Okay, actually, I might as well go ahead and give you some little arrows here. Okay, and then I'm going to continue. Okay, oh, sorry, that goes here. I gave you the wrong arrow. I'm gonna erase that one. Get a little bit smaller. There we go. Yeah, where'd my pencil go? There we go. Okay, so this one should have been right here. 5 times 1. Gracious. 5 times 1. Where's my red? There we go. Right there is 5. 5 times 2 is going to go to 10. I add those up, and that's going to give me a 3. Okay. Then I'm going to take 5 times 3 is 15. If I add those together, -11 and 15 is a positive 4. Then 5 times 4 is a 20. And -20 plus 20 is a beautiful 0 again. So I have another remainder of 0. And we always like those remainders of zeros. Got to pay attention to that. Our quotient is going to be, we're going to have 1 power less. So we're going to have x cubed. So 1x cubed plus 2x squared plus 3x plus 4 with the remainder of 0. So all of these go into their coefficients, 1 power less than we started. And there you have your quotient. Okay? So that is my quotient. In factored form, we have our x minus 5 times all that. And that would give us our that would be factored. That would factor that guy out a little bit. Okay? Okay, so you might want to pause this and divide this and see how you do. Be careful. Remember, there's no squared term there, so you want to have a placeholder of a 0. Okay? So if you're just coming back, we're going to divide by a positive 1, which is our 0. I'm going to put it in the house. I'm going to have all of my, I need a placeholder for the squared term. So I have a coefficient of 3 for my cubed term. I don't have a squared term, so I have to hold that with a 0. Then I have a -5 and a positive 10. Leave myself some space. Always start by bringing down this 3. Okay. And then 1 times 3 is 3. And I'm going to add 3. 1 times 3 again is 3. I'm going to add those is -2. 1 times -2 is -2. And that gives me a positive 8. So this time I don't have a remainder of 0. So now I'm going to have, again, 1 power less. It'll be squared terms. So this becomes a 3x squared plus 3x minus 2. And this time I have a remainder of 8. And I can write this a couple different ways. I can write this as 3x squared plus 3x minus 2 plus, and I can put 8 over x minus 1, excuse me, there as well. Same thing. I can't write this in factored form because they are not factors, right? I mean, I could write it in factors form, but I'd have to take into consideration my remainder, but they're not factors of each other, okay? So this takes us to, here's just a little kind of a summary. If you ever want to take a picture of something, this is kind of a good way to kind of take a picture to remind you what to do. It talks about, putting the 0 here, bringing down the 2, multiplying -3 by this term and adding, and so forth and so on. and getting your final solution down there, okay? So now we're going to take a look at the remainder theorem. And the remainder theorem is if a polynomial p of x is divided by a binomial x minus a, the remainder obtained is p of a. That's kind of confusing. So what I'm going to kind of do for you here is I kind of showed you, like, if we have a big polynomial right here, and we want to evaluate it for x equals 3, we're going to get the same thing as if we divide by 3 here, and whatever the remainder is what p of 3 is, okay? And I'll show you what I mean here. So I'm going to do both things here. I'm going to evaluate this guy for p of 3. So I'm going to put in here, I'm going to put p of 3 equals 2 times 3 cubed. So I'm going to plug in 3 for every time I see x, plus 6 times 3 squared, plus 5 times 3, plus 4. So we're just substituting in 3 for x. This is going to be equal to 2 times 27, plus 6 times 9, plus 15, plus 4. Okay? This is going to be 54, plus 54, plus, I'm going to put that 19. This equals 108. Whoops, 108 plus 19, which is equal to I think it was 127, I believe. Okay? So p of 3 equals 127. I can't write that, okay? Now next, what I'm going to do is divide. So if I take this positive 3, the 0, 3, and divide into this polynomial, 2, 6, 5, and 4. If I drop this 2 down, it's the first step always. I'm going to take 3 times 2 is 6 and add those. It gives me 12. 3 times 12 is 36. I'm going to add those together. It gives me a 41. And then I'm going to take my 3 times 41. What is that? I don't even know. 3 times 41. I should know that. 123. Add those is 127. And you'll notice it. Look at that. So that is a remainder. And that's what the remainder theorem says, is that p of 3 is the same thing as whatever the remainder is whatever the remainder is if I divide. Okay, so it's the same thing. So sometimes if you have to evaluate something, it's a lot quicker to actually divide than it is to go through this whole evaluation process. So we know that whatever we want to, p of a is always equal to whatever the remainder is when I divide. Okay, and so that is the remainder theorem. Okay, and so right here, here's an example. The population of tortoises of an island is modeled by this function here, where x is the number of years since 2015. Use the remainder theorem to estimate the population in 2023. So from 2015 to 2023, 8 years have passed. So I can either evaluate p of 8 years and plug it into that entire equation, or I can just evaluate 8. Okay, so this would be the same thing as x minus 8, right? Same thing. So I'd actually divide by 8. So notice that that's kind of the same thing. I'm not going to change the sign of 8 because it's the same thing as x minus 8. So I'm still dividing by positive 8. So I'm going to divide by 8. I'm going to put that into -1, 6, 12, and 325. So I bring down my -1. 8 times -1 is -8. And that's a -2. 8 times -2 is -16. And that is -4. 8 times -4 is -32. And that gives us 293. So my population after 8 years is going to leave us with 293 tortoises after 8 years. It's in 2023. Okay, so that's kind of how that works. Now, this was a little bit shorter, I think, than actually plugging in 8 into all of these, but you can still plug in 8 into all those and evaluate and still come up with 293. Okay. Okay. So you can go ahead and try this. Use synthetic division and remainder theorem to find p of a. So if a is equal to -2. So again, remember, if that's a, I'm going to find p of -2. That's the same thing as x minus a, which x minus -2, which becomes x plus 2. So that would be my factored form. So I'm still dividing by -2. So people always get confused on what do I divide by, 2 or -2. This is my factored form, x minus a. So then whatever a is, I plug that in there, right? Plug -2 into there. And so that gives me x minus -2, which is x plus 2. So I'm dividing by the 0, -2. Okay? So -2 into all this gobbledygook, so into 1, 8, 12, and 5. Bring down the 1. Negative 2 times 1 is negative 2. That's a 6. Negative 2 times 6 is negative 12. That's a 0. And then negative 2 times 0 is 0. And I'm left over with a 5. So this is going to be x squared plus 6x plus 0. We're not going to put anything there. We just have a remainder of 5. Okay. And that's it. Okay. So that is the remainder theorem. So the one last thing we're going to talk about today is called the factor theorem. This is super important. So just like if I take 7 into 15, it goes into it 2 times, and that's 14. We have left over 1. So those are 7 and 2 are, this is not factors of 15. It doesn't go into it evenly, right? But if I take 2 into 68 and go through my all division process, when I have a remainder of 0, that tells me that 2 and 34 are factors of 68, okay? And so that's how we kind of find factors of our polynomials, is when we have a remainder of 0, kind of like we did on that very first slide. So a factor theorem just basically says that the binomial x minus a is a factor of the polynomial if and only if f of a equals 0. In other words, if my remainder is 0. Okay, so that's what we always want, is my remainder to be 0. So we're going to check and see if these are actually factors. So how can you use the factor theorem to determine if a given polynomial is a factor? So we want to see if x minus 3 here is a factor. So we're just going to use division. Okay, so we divide by the 0, and the 0 here is 3. Okay, so I'm going to put 3 here in my house. Make sure all of my exponents are accounted for. 3, 2, I'm missing 1, so I have to put a 0 there. So I'm going to go 1, negative 2, I'm missing my x term, so I'm going to put a 0 there, and negative 4. Got a little reminder over here, when using synthetic division, remember to include 0. Okay. All right, I'm going to bring down my 1. Always for my first step here, bring down my 1. And then 3 times 1 is 3. I'm going to add those together, and I'm going to get positive 1. 3 times 1 is 3 again, and I'm going to add those together, and I'm going to get 3. 3 times 3 is 9. And add those together, and that's 5. Okay, so since I have a remainder, these x minus 3 is not a factor, right? Not a factor of x cubed minus 2x squared minus 4, okay? And that's it. We're just trying to figure out, is it a factor or not? In this case, it is not a factor, okay? So how about this one? Can we figure out if x minus 4 is a factor here? So we're going to divide by 4. And hopefully at some point, you guys are going to get really fast at this division, okay? We have all of our powers, so 1, negative 10, 28, negative 16. Drop down my 1. 4 times 1 is 4, and negative 10 plus 4 is negative 6. 4 times negative 6 is negative 24. Add these two together, I get a positive 4. 4 times 4 is 16, and we get a 6. And so this right here is beautiful. Okay, so that means yes, x minus 4 is a factor. And to write it in factored form, we're going to take x minus 4 times our result that we got down here. And so remember, all of this is 1 less power, so it's going to be x squared minus 6x plus 4. And that should, this together, this whole thing right here, if we multiply that together, we should get this back, okay? Now, if we're trying to solve for this, now all we'd have to do is take this quadratic and factor that guy, if we can. In this case, we can't, right? So we'd have to use quadratic formula or something else. That's how we solve for polynomials. So kind of keep that in the back of your head between now and next week, okay? This is how we start to factor polynomials, okay? The question is, how do we find which 0 to divide? That's another trick, okay? So you try it right here. Check to see if x minus 1 is a factor of this polynomial, and then come back and see how you did. Okay, so we're dividing by 1. Make sure all of our powers are accounted for, which they are. So we have 3, 1, negative 10, and 6. Drop down my 3. 1 times 3 is 3. Add these together, which is 4. 1 times 4 is 4. Add those together is negative 6. 1 times negative 6 is negative 6, and that's a 0. And again, That's what we look for. That means it's a factor. So that means that this is going to be a 0. So x minus 1, that's my factor. And then we have left, our quotient down here is going to be 3x squared, it's 1 power less, plus 4x minus 6, no remainders, right? So this right here is in factored form. If we're going to solve this, we're going to take this and put it in the quadratic formula or something else to find the rest of our zeros. So kind of put that in the back of your head for next week when we start solving the rest of the way. Right now, we're just learning how to start putting them in factored form a little bit, okay? So we're just checking to see if they're factors. In this case, x minus 1 is indeed a factor, okay? All right, so here is kind of some long division, what it looked like. Here's my synthetic division. That's kind of a summary of what we've done. I know this is a little bit long. Thank you for your patience, but it's going to be worth it. Make sure you really wrap your head around synthetic division. It's going to be very, very important, as well as the factor theorem, okay? Remainder theorem, yeah, you need to know it, but factor theorem, they kind of go hand in hand, actually. So you have a 3.4 day 2 Excel. Don't forget to attach your work, and I will see you all on our next Zoom. Have a great night. Bye.